Hello good people, I'm going to talk about oxidation numbers and charge. Firstly, the good news. Although technically speaking, oxidation numbers and charge are not the same thing, for the purposes of this course, we can treat them as if though they were the same thing. Before I talk about the oxidation numbers, I'm going to do a bit of revision. The periodic table of elements provides a wealth of information. Right now, I'm going to zoom in on fluorine. So what is the information contained within this rectangle? The red number 9 gives me the atomic number. Down here in orange, I have the average atomic mass. Further down in blue, I'm given clues about the electron configuration. You might be wondering, how do these two numbers give me a clue about the electron configuration of fluorine? Let me write out the electron configuration of fluorine. Fluorine has 9 protons, therefore 9 electrons. So I will have 1s2, 2s2, and 2p5. How does this relate to the numbers 2 and 7? Well, let's think in terms of energy levels. The electrons of fluorine occupy two energy levels, energy level 1 and energy level 2. How many electrons are present in each energy level? Well, energy level 1 has 2 electrons, that's this 2, and energy level 2 has 7 electrons, 2 plus 5 is 7, and that's this 7. All right, what about this negative 1? It looks awfully like a charge. This value here is known as the oxidation state or oxidation number. In case of fluorine, I could say that this oxidation number of negative 1 is essentially the same as the charge of a fluorine anion. Recall, fluorine is a nonmetal, it will gain 1 electron, and therefore I will end up with a fluorine anion that I could write as F, and then in the upper right corner, a minus sign. This minus sign indicates that when it comes to protons and electrons, the fluorine anion has an extra electron. This means that I can use the oxidation number as a shortcut to quickly tell me the charge of an ion. Let's look at another example. Now we have potassium. Can I still use the oxidation number as a shortcut? Potassium is a metal, which means it is likely to lose an electron. Potassium is a group 1 metal, which means it's going to lose 1 electron. This in turn means that when it comes to protons and electrons, potassium will have 1 less electron. And as a result, the potassium cation has 1 more positive charge than negative charges. So the symbol for the potassium cation would be K, and now in the upper right I would place a little plus. So here too I can use the oxidation number as a shortcut. The oxidation number is +1 and the charge of my cation is a single plus symbol. So this is a neat little shortcut that we can use so long as there is only one oxidation number. And by the tone of my voice, and the fact that this lesson exists at all, you can probably already guess that this is not always the case. Let me bring in sulfur. Sulfur has 4 oxidation numbers. And now, the charge of the ion and the oxidation number are not necessarily the same thing. And this means that you cannot use the shortcut of equating the oxidation number to the charge of the ion. You have 4 choices. Which one do you pick? We do not leave it to Lady Luck. We use our understanding of trends within the periodic table. Sulfur is a nonmetal. Nonmetals have a tendency to accept electrons. This means that sulfur will give a negatively charged anion. How many electrons will it accept? Well, I'm going to go back to the valencies. Starting on the left, group 1 has a valency of 1, then a valency of 2, then group 13 has a valency of 3, then valency of 4, and now I go back 3, 2, 1. Sulfur is in group 16, which has a valency of 2. I have already determined that sulfur is a nonmetal and therefore will accept electrons, and this valency of 2 is telling me that it will accept 2 electrons. This means that overall, the sulfur anion will have 2 more electrons than protons. And so the symbol for the sulfur ion will be S and then a 2 minus. At this stage, you might be wondering, well, what is the purpose of these other oxidation numbers? That is a story for another time. At this stage, keep in mind that if you have a single oxidation number, you can use that as a shortcut to give you the charge of the ion. But if you have multiple oxidation numbers, then you need to go back to the trends within the periodic table and the valencies. That is all for now, and I will see you on the flip side.